Hey guys! In this tutorial, I'm going to show you how to further extend your editor by adding your own custom asset categories in the right-click menu of the content browser, and you'll be able to create your own custom assets that you can create from this menu. And you'll even be able to double-click on these in the content browser to open a custom menu that you can create however you want and lets you edit the data in this asset. Now, these tabs are created using Slate, and you can customize them however you want, including adding things like graphs and nodes, and you can even save the stuff here into your asset, and it'll be persisted when you open it back up. So let's get started. So as usual, I have a pretty empty project here. And the first thing we want to do is create a custom asset type. And I'm going to show you how to add our asset to the right-click menu in the content browser here. And we'll have both our own category, and you'll be able to create that asset throughout this menu or with this menu. So first, we're actually just going to create a plugin that will house our custom asset and the editor code, just to keep everything nice and organized. So if you go to Edit Plugins, you click Add, give it a name, and I'm just going to call this Custom Asset Editor. And you can fill out whatever information here you want. And we just want it to be a blank plugin. We don't need anything in it. And we'll hit Create. So that might take a little while, but that's okay. And now we can close the editor. And I use Visual Studio Code. This might look a little bit different for you in Visual Studio, but I have the source on the left here. And inside the plugins folder, you can see that it created another folder called Custom Asset Editor. And under that, we have a source directory with private and public, and we have a plugin file. So the first thing we want to do is open the plugin file, and we actually want to create a second module. So we're going to have two different modules with this plugin. One of them is going to be the editor components that should not be distributed with the game, and the other one is going to be the runtime components, which will include the new asset that we're creating, because obviously when you create it, you're going to want it to actually ship with your game as well. So we'll have the base module be the editor one. So I'm going to change this type to be editor instead of runtime. And then we're going to create a second module. So you can just copy and paste the first one. And I'm just going to put a runtime suffix on this. You can call it whatever you want. And this is going to be runtime. So then we need to make the source code for the second module. So I'm going to right click over here and just do show in Explorer. And then you can see we're in our source directory and we have custom asset editor. So this is the editor portion. I'm actually just going to copy and paste this, and we'll make the runtime one. And then we just need to change the name. All these custom asset editors need to become custom asset editor runtimes. So we'll rename the build script, and I'll even open that up and we'll find and replace all of the custom asset editors with custom asset editor runtimes. So replace all those. And then we need to rename our header file, put runtime after that, put runtime after this. And we need to replace everything inside those files as well. And that should be all we need to do. Now, the next thing we want to do is set up the dependencies. So I'm going to first go to our tutorial project, and we'll open that build file, which is in tutorialproject.build.cs. And we need to make it depend on both the editor plugin and the runtime plugin, or the runtime module part of the plugin rather. And so the first thing I'm going to do is I like to put these all on their own line. So we'll do that real quick. And we want to depend on the custom asset editor runtime. And we also want to depend on custom asset editor, but I'm actually going to do that as a separate step because we only want this included if we have the editor target building. So I'm going to say if target.bBuildEditor, then I'm going to add these dependencies, but we only need one. So this will just be custom asset editor. And there we go. So we're going to depend on the runtime one only for the for all targets. And we're going to depend on just the editor one for the editor target only. And then if we go back to our editor module. If I go to the custom asset editor, source, and build, this also needs to depend on the runtime plugin because it's going to be accessing that asset. So we also want to add the same thing here. And while we're here, there's actually a few other things that we want to put in here. We're going to need a module called IAssetTools, and we're going to need one called Unreal Ed, which stands for Unreal Editor. And because this is an editor-only module anyway, we can just include them directly right here. And that should be all the dependencies we need between the different modules. So now the next step is to start adding our code. So let's start with the actual asset, the custom asset that we want to create. And this assets are like materials and whatever UObjects you want to create in your content browser. Then this is what we'll be able to create through the content menu. So if I go to our runtime plugin, since we want this available at runtime, I'm going to make a new file and call it custom asset. Custom asset.h and progma once. We're going to include core minimal, and we're going to include custom asset.generated.h, just the usual boilerplate. And we're going to make a U class. We want this to be a blueprint type since we're going to be accessing it in the editor. And we're going to do class and custom asset editor runtime API. And this is important because we're going to be using this class in other modules, so it has to be exported. And let me just make sure I typed that right. I did. And uCustomAsset is the class name, and it's going to be a UObject. So we won't add anything to this yet. We'll just do generated body so we can create it, and we'll come back to actually add properties here. But for the moment, we'll just have a UObject called custom asset. And so that's all we need to do here. We can create a CPP file for it. Probably don't need it yet, but we'll just include customasset.h and leave that alone for the moment. So at this point, we have a custom asset that is accessible, but it's not going to show up in the context menu. So the next step is to make it show up in the context menu. So in order to make this show up in the context menu, we need to implement what's called an asset type action. So everything that shows up in there is a type action, and there's a class called FAssetTypeAction space that every action inherits from in order to do this. So we're going to first create a header for this, and we'll just call it custom asset action. And then we'll do the usual boilerplate, progma once, and we actually probably just need core minimal. And we will need the asset type actions class as well. So asset type actions base.h. And by the way, this is also the module that we depended on. If you remember earlier when we were in the build script, that comes from this IAssetTools module. So make sure that you're dependent on that as well in your build script. So back in our custom asset action.h, we can actually declare the class. So I'm going to do class custom asset action. And we're going to extend from FAsset type actions base. So in here, we just need a constructor, and the constructor needs to take a category. So we're going to call it custom asset action asset type categories category. And if we look at this enumeration, you can see this is the category that it's going to be added to. So these are the built-in ones that you can see when you right-click normally, but you can actually add custom user ones, and I'll cover how to do that in a little bit. And that's why this constructor needs to take in what the category is so that it knows what to register as. But for the moment, let's finish this interface. So this needs to be public. And now we need to implement the interface of FAsset type action space. So just mark that as the interface section. So these are all methods in our parent class, and they're all going to be virtual. So first one we need is virtual ftext getName, and that's constant, and we're going to override. And this is going to tell Unreal what the name of our action is. And then we need the color of it. So fcolor get type color. It's also constant. We need to tell it what class this is going to create. So get supported class, again, const override. It needs to know what to do when you double click on it and what kind of editor to open. And this is what we'll do this in a later part, but we need to make the interface for it now. So open asset editor. And this takes a whole bunch of parameters, takes a array of view objects as in objects. It takes a shared pointer to a class called iToolkitHost. We'll talk about that later. And that actually has a default value of tshared pointer iToolkitHost. So just the default constructor. And this overrides as well, but is not constant. And then the last one is we have to tell it what categories it's part of. This can be one or more. So we'll do virtual uint32 get categories. And this is an override as well. And the reason it's a uint32 and not eAsset type categories is because it's actually a, so each category is a power of 2, so you can combine them together. And it just returns the combination of all the categories you want to be in as an integer. So there's actually a maximum of probably 31 categories, because I think the last one is means none. But yeah, so this is the interface that we need. And while we're here, we're going to need a member variable for the category that's passed in. So we'll just make a place to store that here. And now we can make the CPP file for this and actually define what all these things are. So I'm going to do custom AssetAction.cpp. We're going to include custom AssetAction.h. And we're going to just copy all these methods we need to implement, including the constructor. So I'll just copy paste those in here. We don't need the public, and we don't need all the virtuals. And we can start implementing the constructor. And I think I have an extra space here. Get rid of that. Oops. So all these are part of custom asset action. So add that into all of our methods here. And now we can start implementing. So in the constructor, all we actually need to do is just assign our asset category member that we made. So asset category equals category. So we'll hang on to that for later. We don't need it at the moment. And then for the name, we're just going to call this my custom asset. And we're not going to worry about localization for right now. So I'll just do ftext from string. And we'll give it my custom asset. In reality, you probably want to use the ns-loctext macro to do this, but I don't have a localization category or anything set up. So we'll just do this. And for the color, let's just do fcolor cyan, or pick a color, whatever you want. And we'll return that. For the supported class, this is where our custom asset that we made before comes in. So we have to tell it what class we actually want to create here. And so first we need to include that. So pound include custom asset.h. And then in get supported class, we just do return view custom asset static class. Now for opening the editor, we'll do this in a later section. So I'll just leave this as a to-do for right now. And for get categories, we just want to return the asset category that is passed in. And I'll show you how to get that in a moment. Now, this get supported class tells the editor what class it is, but it doesn't tell it how to create a new one. And so we actually have to create another class called custom asset factory. So if I go new file, custom asset factory, and we'll make a header file and a CPP for it. And as usual, we progma once, include core minimal, and this is going to be a UObject, so include custom asset factory.generated.h. So this is a U class. Let's going to be custom asset factory, and it will extend from a Unreal class called uFactory, which is a uObject, and we need our generated body and a constructor. And then we need to implement the uFactory interface as well. So all this really needs to do is return a Boolean if it can create a new object or not, and it has a method for actually creating that object. So first, the method for creating the object is just virtual uObject factory create new, and it takes the uClass, it takes the parent uObject in parent, takes a name, takes any flags to give the object. And this is just all stuff that we're going to be passing directly to the object that we created. And it takes a feedback context if there's any errors. So that's the signature for that one. The second method we need is virtual bool can create new. Const override. And this will just return if we can create a new object or not. So just like we always do, we're going to copy paste these methods into the CPP file. We can include custom asset factory to start, and we'll implement these methods. And the constructor needs to call the superclass, so super object initializer, so that it can initialize. And then all we need to do in here is set what the supported class is for the factory. So supported class equals u custom asset static class. And we need to include the header for that, so include custom asset.h. And then for factory create new, all we really need to do is just make a u custom asset. And this is that runtime asset that we created a very long time ago. And we'll just do a new object. And we'll give it the parent, the name, and the flags that we're told to. And then we can just return that. And for can create new, we'll just always return true. You could create, put logic here for, if you had any reason why you couldn't create a new one. Maybe you have like a max number of that kind of object that can exist or something like that. But we don't have that, so we'll just return true here. And so that's all the classes we need. So now we just need to register this stuff with the engine so that it knows that it exists. Now, the factory, we actually don't have to do any kind of registration process because it actually just iterates over all U objects in the project. And if they're factories, it adds them. Maybe not the best way to do it, but it is how it works. But we do need to register the custom asset action. So if we open up our custom asset editor.cpp, this is where the module code is. First, we need to include a few things. We're going to need the custom asset action, obviously. That's what we're trying to register. We're going to need what's called the IAssetTools.h. This is how we interface with the engine's registration for these things. And we want to include the AssetTools module as well. This is the module that IAssetTools is contained in. And we also added it to our build script before as well. All right, and then when the module starts up, this is when we want to start using these things. So first thing we need to do is get the module. So IAssetTools AssetTools module equals IAssetTools get. And then we want to get a category. So that custom category that we passed in, this is how we get what that is. So this will create a user-specific category that's not in that enumeration we looked at earlier and return it. And then we can in turn pass it to our custom asset action so that it knows which category it's in. So we're going to do eAsset type categories, type, asset type, and we're going to set it equal to the AssetTools module dot register advanced asset category. And then this is going to take a name, so fname, and we'll just give it custom assets for the name. And then it needs the user-facing name for it, and we're not concerned with localization, so we'll just do ftext from string and give it custom assets. So this is what the user will see in the right-click menu when our asset category shows up. So next we want to create our custom asset action that we want to put in the menu. So t-shared pointer custom asset action. And we're going to make a shareable new custom asset action. And we give it that asset type. And now lastly, we need to just register the action. So IAssetTools module dot register asset type actions. And we'll do custom asset action dot to shared ref. And this is all we need to do to get it in the context menu. We made a category and we made an instance of our custom asset action, and we register the asset type action. Now, if it doesn't actually show up when you do this, make sure that you have the custom asset factory created and that the class that it returns is the exact same custom asset class. Because like I said, you don't actually register the factories manually. It searches for them by iterating over all UObjects at startup, and then it associates the actions with the factory by what this returns. So just make sure that that's correct. And now we should just be able to build and run. And it looks like I have a typo here. Like I have a capital N that should be lowercase, and it's probably like that in the CPP as well. Go ahead and fix that and build and run again. All right, we're back in our editor. We have our content browser here. So if I go to content and right click, you can see now we have a menu entry called custom assets, and my custom asset shows up. If we click on it, it creates my custom asset here, and we can give it a name. And there we go. We have a way to create custom assets now in our editor. But you'll notice if I double click it, nothing happens. Whereas if you open anything else up in here, it will open an editor. And so we're going to want to be able to create an editor too, and we're going to want to be able to set what the UI here looks like. So in the next part, we're going to handle how to open an editor when one of these gets double clicked. So for this next part, we're going to be adding a window that comes up when you double click on one of these custom assets in the editor, and it'll let you add your own UI and your own customization for how you want to modify these objects when they're being edited in the editor. So the way that Unreal handles this is there's a class called FAssetEditorToolkit, and any window or any editor that comes up extends from this class. And this class is both responsible for showing the editor and for controlling it. And more specifically, we're going to be extending a class called FWorkflowCentricApplication. And this extends FAssetEditorToolkit, and it adds some more functionality to it as well. And the main difference between the two is Asset Editor Toolkit basically assumes that you have just one mode and just one set of tabs that come up, whereas Workflow-centric application adds a concept of having multiple modes, and each mode can have its own set of tabs. So that's usually the more common one to use, so we'll start with that one. And it does some work for us as well to make it a little bit easier. So to get started, we're going to make something called a custom asset editor app. And this will extend the workflow-centric application. So in our editor module here, I'm going to make another header file called custom asset editor app. And we'll include the usual stuff. And we're also going to include workflow-centric application. So that's in workflow-oriented app / workflow-centric application. And then we're going to make a class. This one's not a UObject. So called custom asset editor app. And it's going to extend FWorkflowCentricApplication. And we'll extend a few other things just to get undo redo support. And if we ever want to be notified of changes, we can extend fNotifyHook as well. So fEditor undo client, and F notify hook. And we won't go into those now, but maybe a future tutorial we can talk about those. So first we're gonna overload the register tab spawners. So basically the way that a workflow-centric application works is you have a list of tab factories. So each tab in your window will have a factory that knows how to create it. And that will fill out the actual user interface that comes up for each tab. And the user interfaces are written using Slate, not with UMG. So if you're not familiar with Slate, there's other tutorials that can show you how to use that. But we'll just use a very basic form of it. So you won't have to know a whole lot about how Slate operates, but that's how UIs are defined. And so this method, register tab spawners, is how the workflow-centric application tells the parent class what tabs that it has. So the argument it takes is a shared ref to an ftab manager. Okay. And then we also need a method to initialize everything. So we're just going to call this init editor. And we need to take the mode. So this will either be standalone or running in the editor. It'll probably almost always be running in the editor. And it'll take a shared pointer to an iToolkit host. And we'll talk about that in a second. And it'll take the UObject that we are modifying. So this will be our custom asset. So then for the parent class, the FAssetEditor toolkit, we need to override some things to basically tell it what everything's called and fill out, what the tabs are called and the colors and things. So the first method is the toolkit name. So virtual fname get toolkit. Oops. Get toolkit fname. So we're just going to return fname text custom asset editor app. So that's what that's just a unique name to identify this editor. And then ftext get base toolkit name. And this is going to return the user facing name is going to be. So return ftext from string text custom asset editor app, whatever. Then virtual fstring get world centric tab prefix. And we don't really care what this is, so custom asset editor app, whatever. And then we need to give it the color scale for the tab color. So this will just multiply by the default, so you can change the tint if you want to. So get world centric tab color scale. And we'll just return like a shade of blue. And make it 50% transparent. I missed an F. And oops, that's supposed to be 0.5. Okay. And you can give it the documentation link for this that will open. So get documentation link. And I'll just put my GitHub here. Okay, and then there's two events for when hosting starts and hosting finishes. They need to be implemented, but we don't need to do anything with them. So virtual void on toolkit hosting started. And it takes a t-shared ref to the toolkit. Like I said, we have to override it, but we don't have to implement it necessarily. And then there's another one for on toolkit hosting finished. And takes the same arguments. So this is the interface, kind of a mouthful, but If you don't implement these things, you'll get linker errors complaining that they're not there. And I believe this is the bare minimum set of things that you need. So they're all implemented here. We don't need to do anything with those in the CPP file, but these other two we do need to implement. So let me copy paste those and make a CPP file. So we'll have custom asset editor app.cpp. We'll include custom asset editor app.h, and we'll implement these methods. All right, so register tab spawners. All we need to do here is just call the FWorkflowCentricApplication version of this. So register tab spawners and just pass it the tab manager. And for an editor, so this is where we actually launch the window. So we'll take the object that gets passed in, and we need to make an array out of it. So we'll do tarray, uObject, objects to edit. There could be more than one potentially. This will only support one at a time. So objects to edit, add, and we'll give the object that was passed in. Now we're going to call a method initAssetEditor, and this is in the parent class to workflow-centric application in FAssetEditor toolkit interface. So if you weren't using the workflow-centric application override of it, you would still call this method, and this is what actually launches the window. So this takes a few arguments. So the first one is the mode, and we just, this is passed in, so we'll just forward that through. The second one is the toolkit host. So we'll just, again, forward what's passed in. Then the third argument is the name, so custom asset editor, or rather the identifier. Third one, or this one is the layout that you want, but our we're actually using application modes, which I'll talk about in a second, and they'll set the layout. So for the moment, we can just do no layout. So F tab manager, F layout, no layout. And then this is if you want to create a standalone menu. We do. And there's a boolean if you want to create the default toolbar. So sure, whatever. And lastly, you pass in the objects to edit that we made. And that's it for now. We'll come back to this because if we were to run this right now, it'll just launch an empty window that doesn't do anything. But before we continue with this function, we need to create a couple more things. So I mentioned that each tab that you want to display in the application has to have a factory associated with it to create the tab when it's necessary. And so we're going to create a custom asset primary tab factory. And you could have more of these if you wanted, but we'll just do one for now. So custom asset primary tab factory. .h. And the only reason I had primary in here is because you might have like a primary tab, a secondary tab, or you could have some other name for them depending on what you're doing there. But I don't have any creative names right now, so we'll just call it the primary tab. And then we'll pragma once as usual. We'll include core minimal as usual. And we'll include workflow oriented app, FWorkflowTabFactory. So I'll make our class custom asset primary tab factory, and it will extend FWorkflowTabFactory. So we need a constructor, asset primary tab factory, and we're actually going to pass our application in so that it can access the object and things in there. So t-shared pointer to class custom asset editor app, the class we just made. And then we're going to override two methods. So first one returns a shared ref to a widget and is called create tab body. And this is what actually creates the user interface for this particular tab. So it takes a workflow tab spawn info. And then the second method, virtual ftext. And this just gives the tooltip text for when they hover over the tab. So get tab tooltip text. And once again, it takes an FWorkflow tab spawn info. Okay. And while we're here, we also want, we were passing in the application, so we want to hang on to that. But we're going to hang on to it with a weak pointer so that we don't create a reference cycle between the application and this tab. So there are no reference cycles for U objects, but because we're using shared pointers on non-U objects here, we do have to worry about reference cycles. So that's why this is weak. And so we have our app member variable as well. So that's all we need in this class. Let's just implement the methods and create a CPP file for it. So I'll do new custom asset primary tab factory.cpp. We'll include custom asset primary tab factory.h. And we'll implement our methods here. All right, and we forward declared our app in the header file, so we need to include it here. So include custom asset editor app.h. And our constructor actually needs to call the parent constructor as well. So FWorkflowTabFactory. And it takes the identifier of this tab. So this will just uniquely identify the tab. So we'll just call it custom asset primary tab. And if you had another one again, that would be, custom asset secondary tab or whatever you want. And this will take the application as well. That's all we need to do there. And then in the constructor, first of all, we want to set our app pointer to the app that's passed in. And then you can set some things about the tab, like what the tab label is, its description, and the view menu tooltip. So I'll set the tab label. And we'll just call it primary. And we can set the view menu description if we want. Again, we're not worried about localization here. Displays the primary view for whatever you want to do, whatever. View menu tooltip. And show the primary view. So that's good. So then all we need to do in these other two methods, create tab body. Again, this is where the magic kind of happens, where we create the slate UI that we want to display in the tab in our editor. And this is where you'll actually put widgets or graphs or whatever you want to actually modify the data in your custom asset. And we will do that, but in the last part of this video. But for now, let's just return something very simple. We'll just do slate new text block, and we'll set some text on it. And this is a text widget created for the custom tab. Okay. And so that widget will be displayed in our tab. And we can, if we want custom tab tooltip text, we can put that here as well. And we'll just say primary view for doing primary things. Very cool. All right, so now we have the factory that will create tabs when our application mode is shown. And so each application can have multiple modes. Each mode can have different tabs. And so we need to create at least one mode that we will set up when the application launches. You can have more than one mode. We'll just do one for now. And we'll call that custom asset app mode. So I'm going to make another header file, custom asset app mode.h. And we'll do the usual core minimal include. And we need a few other things. We need the workflow-oriented app application mode. And this is what we're going to be extending in this class. And we need the workflow tab manager as well. Workflow, and I'll just copy this. Workflow tab manager. So we're going to do class custom asset app mode. And we're going to extend F application mode. And we need a constructor, custom asset app mode. And we'll take a shared pointer to custom asset editor app, just like the tab did. And then we have 3 methods we need to override here. So the first one is register tab factories. And this takes a shared pointer to the tab manager. And that'll say which tabs that we want in this mode. And then we have a callback for deactivate mode. This gets called, or pre-deactivate mode rather. This gets called right before if the mode's going away, essentially. And likewise, we have a post-activate mode, which gets called just after the mode is activated if you want to do anything when it first comes up. And we need a couple member variables here. Once again, we'll have a weak pointer to our custom asset editor app. And we also, there's a handy class that already comes with all this stuff called FWorkflowTabFactory. And this is going to be a list of the tab factories that are associated with this mode. So if you had more than one tab, you would add them each, or you could add multiple to this list. We're only going to have one tab in this tutorial, but just know you could add as many as you wanted here, and they would just show up as well. So now we're going to go implement these methods. So we'll make the CPP file once again. And quickly implement all these. There we go. And we're going to need a couple of includes here. We're going to need the applications, custom asset editor app, once again. And we're going to need the tab factory, since that's how we're going to get the tab that we want this mode to display. So custom asset primary tab factory.h. And in our constructor, it needs to pass the tab manager to the superclass. So FApplicationMode. Oops. Or sorry, it doesn't need to pass the app. It needs to pass the a unique identifier for this mode. So usually you would define this somewhere so that you don't typo it, or if you change it, you don't have to go back to every place that references it and change it. But again, this is a tutorial. We'll just put it here and copy paste it for now. So we want to keep track of the app that gets passed in. And actually, I'm sorry, I didn't even include the constructor in this file. Let me do that real quick. And sorry, this is not the constructor. The constructor's up here. And anyway, we want to keep track of that app that gets passed in. And we want to register all of our tab factories and put them in that tabs list. So we go tabs, register factory. We're going to make a shared pointer, so make shareable, new custom asset primary tab factory, and give it the app. And this is how we give it the tabs that we want. If we had multiple tabs, you just register each one of them here in this tabs array. And we can also specify the tab layout. And we just set a variable called tab layout to ftab manager, new layout. And this identifier is how when you close an editor, it will remember your layout. And it uses this identifier to decide which layout it is. So if you were to change this to something incompatible with the previous layout, you'd want to update this, the version number in this identifier or something. So we're going to call it custom asset app mode layout, and we'll just put a version on it. So if you were to change it, you'd call this, v2 or something. And then we're going to say add area, and this is all Slate stuff. So again, might do a separate tutorial on Slate if people are interested, but there's certainly a lot of tutorials out there for it. And we're going to do ftab manager new primary area. We're going to set the orientation to vertical. And we're just going to split it once. And we'll make a stack. And that stack will have one tab. And this is how the layout associates where the tab goes in its layout. And we're going to give the custom asset primary tab as the identifier. And this needs to match the name of the primary tab that we did before. So again, you'd probably want to put this in a header file somewhere so that it's the same for both, but we'll just use the same one for now. And we want to pass an initial state for it for open tab. So that's it. That's our layout. So now in register tab factories, this is where we give the application our list of tabs. So first we need our application. So shared pointer, custom asset editor app. And we're going to pin our weak pointer. And we'll say app push tab factories. And we give it that array of tabs that we registered all of our tabs with. And then we'll just call the parent. So FApplicationMode, register tab factories, and in tab manager. Okay. And then for pre-activate mode and post-activate mode, we don't need to do anything here. You can add stuff here in the future if you want, but we'll just call the superclass here instead. But yeah, if you wanted to do something when the window goes away or comes up, this would be the place to do that. And so that is everything in the mode. So just to recap real quick, we had to create the custom asset editor app. So this is the application that owns the editor window. And then we needed a tab factory. You need a tab factory for each tab that you want to show up in your application. You need a mode, and you need one mode for each unique set of tabs that are going to be associated with your application. So like if you had a blueprint editor, that might be different from like your graph editor or something like that. And so you'd have a different set of tabs in different modes for each one. So for this tutorial, we're just going to have one mode and one tab. And then last thing we need to do now is actually use, we have to tell it which app mode that we're going to be using. So if we go back to our application, remember we started in init editor and we're showing the window with init asset editor. And so now with FWorkflowCentricApplication, you want to add each type of mode that you have. So add application mode, and you give it the name, and this has to match exactly. So custom asset app mode is the one that we made. And then you give it a pointer to a custom asset app mode, which takes the app. And we also need to include that. We'll include custom asset app mode. And then lastly, we need to set the current mode. So set current mode to custom asset app mode. And I believe that is all we need to do. So now when we double click one of our custom assets, it should open an editor. The editor should have a tab, and the tab should have a text block that is set from our tab factory. And it'll say this widget was created for the custom tab. So let's build and run. And as usual, I have a typo somewhere. So let me fix that real quick. I'm missing the wap here. And I think I have another typo. These E's shouldn't be capitalized. And just one more. No, this is add tab, not ab, in our custom asset app mode. Oh, and I almost forgot the most important part. If you remember way back in the beginning of this tutorial, we left the to do here in custom asset action. And that's when you actually double click on the asset, open asset editor gets called, and we have to actually tell it what to do. So we can finally implement this now. We're going to do first just decide what mode it is. So toolkit mode type. And so it passes in edit within level editor. So if this is valid, then we want to do e toolkit mode world centric. Otherwise, we're standalone. So E toolkit mode, standalone. And then for the objects passed in, for each one we want to edit, we want to open up an editor. So for view object, object, in objects, we want to see if it's a custom asset. So U custom asset. And if it is, then we want to make a shared ref to a new custom asset editor app. And then take our editor and initialize it. And give it our custom asset. And there we go. Now our window should actually show up as well when we double click on it. So let's try this out. Oh, and of course we need to include this as well. Include custom asset editor app.h. And there we go. All right, so now if we right click, we have our custom assets menu. We can create a custom asset. And now if I double click on it, see a window comes up. See we have a tab that says primary. We've got our tooltip, a primary view for doing primary things. And we have a text widget. This is a text widget created for the custom tab. And so now we have a basic UI that we can extend to add whatever edit operations we want. But the last thing we probably want to be able to do is to be able to save and load actual data in our custom asset. And so we will have one more section in this tutorial to show you how to do that. So the last part of this tutorial, I'm going to show you how to modify, save, and load properties to your custom asset from within that editor that we just created. So first let's go to the custom asset header and we'll actually just add a few properties here that we can modify. So we'll make a public section, view property. We want it to be editable anywhere. This is very important, by the way, for what we're doing. Make sure you have edit anywhere in there. So we'll just give it some f string. Let's call it default data. And let's see, we'll give it an integer. So just an int32, some number. And we'll give it a boolean too, why not? Some bool equals false. So just show a few different data types that we can potentially have in our custom asset. And we're going to use a module called PropertyEditor. So in the rest of the editor, whenever you see the lists of properties, whenever you open a blueprint or something, they all use PropertyEditor in order to do that. And we can use the exact same module. So if I open our build script, we do have to depend on it. And the module is called PropertyEditor. So that's all we need to do there. And if we go to our application, we also want to, or probably actually, sorry, the custom asset editor app.h. We want to give access to the asset that we're editing so that the tab has access to it as well. So we'll just forward declare view custom asset. We'll call it get working asset. And we'll return working asset. And we'll define that down here in our private section, view property, forward declare u custom asset, working asset equals the null pointer. And then we need to set that to something in the CPP file. So at the top, we need to include it, include custom asset.h. And then when we initialize, the object gets passed in. And we know that this is only called with custom assets. So we'll set working asset equals cast u custom asset to the object that is passed in. So now we can access the object being edited using our getter method from within the application. And this is actually pretty simple. There's only one more thing we need to do, and that's go to our tab factory. And in our create tab body here, instead of just doing the simple text box, we're actually going to create a details view instead. So at the top, we do need a few includes from the module that we just added, and we also need our custom asset include as well. So include custom asset.h. We're going to include iDetails view. This is the interface to the properties view we're going to create. And we need the module as well. So we'll include PropertyEditor module. So then in create tab body, we need our application. So let's get a pointer to it. Custom asset editor app. And we have a weak pointer member variable we made before. So we'll get that and we'll pin it. And then we want to get the property editor module. So it's called FPropertyEditor module. We'll make it a reference. Property editor module, and we'll use the module manager. Load module checked. And we'll load it by name. And it's just called property editor. So now we have the module. And now the details view takes a bunch of arguments. So we'll just block them so they're easy to set and understand. So we'll make an fDetails view args called details view args. And let's make a little section here for setting all these. So there's a bunch of them. So I'll just make a bunch of these. So let's see, there's B allows search. So we can turn searching off. There's only a few properties, but you can turn it on if you want the search bar. Hide selection tip equals true. And you can go into fdetail view args in the header and see what all these actually are if you want to read the documentation for them. But be lockable, we'll make that false. Oops. Search initial key focus. Sure. Updates from selection. Make that false. Don't need a notify hook, so we'll just set that to null pointer. Show options, we want that to be true. And show modified properties. I want that to be false, although if you want them to show those, you can turn that to true. And lastly, do we want to show the scroll bar? Put that to false. So like I said, you can go into fdetail view args. All those are commented if you want to see what they all do, or you can just play with them and see what they turn on and turn off. So next we need to actually create our details view. So I'm going to make a shared pointer to an iDetails view. And we're going to use the property editor module that we just created, or we retrieved rather. And we're going to call create detail view. And we're going to give the arguments that we just made above. And then we're going to set the object that has the properties that we're viewing. So just call set object, and we'll use the app get working asset that we made before. And now we just need to return a little bit of slate code to wrap that details view and just make it take up all the space. So we're going to do slate new. We'll just do a vertical box container. And the slot's going to just be a vertical box slot. We're going to make it fill the whole container, so 1.0 F for the whole thing. And we'll set the h-align to fill the whole thing as well. And then the child of this is just going to be the details view, and we need to do to shared ref. And that's it. So now we should get a details view that comes up, and it should show the three properties that we set here, some data, some number, and some bool, and we should be able to edit them and save them, and we should be able to load them back after they're saved. So let's build and run that. And of course I have a typo every time. All right, we're back in the editor. Once again, I'm going to right click and create a custom asset, call it custom asset 1. And if I double click now, you see we've got a list of properties here. We have our default data, we've got our default numbers here, and I can change these now. Let's set the number to 5. We'll turn the bool on and we'll say modified data. And we'll say modify data 1. Now if I save that, I close it, and I open it back up, you can see it persisted the data. And you can see I can even close the editor and restart it. And once again, if I double click on it, our modified data has been preserved. And I can even reset these to the default if I want. And I can undo redo that it's all supported as well. So this has been a tutorial on how to create your own custom assets within the content browser, how to modify the right-click menu, and how to use the property details view to actually modify data in your custom assets. So hope you found this helpful. If you like the channel and want to be notified of future videos, feel free to like and subscribe. I'd really appreciate it. And thanks for watching, everyone.